like we tell them the whole process is taken care of. All you got to do is like sit down with us and review what you want on it, review our iterations, and then any ideas you have to change anytime. It's like done. So
that's fantastic, and yeah, that's really sellable because a lot of people are like, hey, I want to have my vision realized, not, you know, oh, I only have this amount of budget and this amount of hours that I can pay for.
So barrier to entry is like removed.
Yeah.
And it's like, I mean, you charge, let's say, for low end stuff, you would do like $150 a month. Lowest I would probably go is $100 because then it just doesn't become worth it. But for someone that has an established business, $100 is nothing. For someone that doesn't have a business, $100 feels like you're choking me out of money.
Yeah.
And so it's like, if you get a small business, yeah, you can probably push. And if you push other services like SEO stuff and whatnot, it could be a pretty good value add for them.
Yeah, that makes sense.
So just finding someone that is just pretty experienced in web development, like it would be a pretty easy task. Especially now, there's so many tools that I generated full websites now with these AI tools, and you can even tell it like edit this. Here's an image of what I want, and it'll like replace it on the site. Like it's just out of control. And so like someone that knows how to use that, like they can turn their work into like 2 hours for site building.
Yeah, that's awesome. It reminds me, I've been doing this, I have this new business model that I've been just itching to try out, which is, it's like the opposite of angel investing in my opinion, because you build an app for pretty much completely free if the company can't pay for it. Like say this is just a brand new startup. But what you do is you put a lifetime on the app's intellectual property. So you write in the contract, look, this starts out with my ownership being this percentage, and it increases over the next 5 years. And at a certain point, I own more than 50% of the company and the product, the intellectual property. And when I own 100%, you're no longer allowed to use it. It's mine. So they don't have to pay you until later. And later on, if they pay you, they have to pay you with compounding interest. So people who have big dreams and believe so fervently that their dream is going to take off, and that they're going to get funding and all of that, it's an easy sell because they're like, okay, I don't have to pay you up front. I don't have money to pay you up front. I have this idea, and I know it's going to take off.
Yes.
And then say it doesn't take off 5 years down the line, it becomes your product, and so you put all the love and focus on that product as you can up front because you want it to be good in case it becomes yours. And then in the short term, it's it'll end up making you money if they invest. If not, you have a product that is an intellectual property in the long run.
I think if you love to build, it's really fun and really cool. But I think if you're actually trying to make money, but with the turnover on businesses,
it
would be hard.
It is.
But again, with these AI tools and like with templates, it's like if you've built apps before, you have a bunch of assets you can just draw from, where your turnaround time might be a week, or maybe 3 days, 4 days of just throwing things together to get an MVP, and it's like that's good enough.
Yeah, exactly. Yeah, I've been itching to try it, but I need the right company where I actually think it might be viable as well. Because if it's not viable to me, then I don't want the intellectual property in the long run.
Are you full stack?
Yeah, I'm hesitant to say that because these days full stack is right? Like
everything.
it's like
everything.
When I was in middle school when I started doing this, I was like, what is a full stack engineer? And back then it was like, oh, knowing back end and front end. 5 years later, I'm graduating high school, and I'm like, what's a full stack engineer? I'm about to go into college. And it's like, okay, front end, back end, DevOps.
Yeah.
And then end of college, I Google, okay, what is a full stack engineer? Now it's front end, back end, DevOps, and cloud. And so I claim to be a full stack, but there's always, tomorrow it's going to be AI, right? So it'll be front end, back end, DevOps, cloud, AI, and then you're screwed because you have to learn a whole new subset of the industry, which is what I'm working on now is AI, because that's not my strong suit. I feel like I've mastered DevOps and cloud somewhat, but just on the idea of I can deploy an EC2 instance, I can deploy Lambdas, I can deploy containerized products.
That's also partly why I get torn of like going so deep into this building the skill of like a full stack engineer, like the old of it, because I'm like, these tools are coming out that will accelerate your learning. If you do want to like get into the weeds, like you can, I mean, I'm sure you already know, it's like with Copilot and stuff, you can stop the process of being stuck in debugging, where you're like, if I just wait a little longer, I'll be able to type in, it'll build me an entire like mobile app, and then I'll talk to it, and it's like, as long as I have the foundations there, I can work with it. And as an entrepreneur, I care more about being like a jack of all trades than like a master of one.
Yeah.
So it just gets interesting.
No, that's very true. Yeah, it's tough in the industry. I'm opening up Discord because that's where we host our online meetings. I'm a little out of it today. I forgot to put all this up. I've just been working on a project, super into it.
What project?
I'm working on an independent project where I'm creating a AI model for essentially interpreting menus. Like, you know how you get on Google Maps and you look at the menu and it's just like some really ugly picture.
Yeah.
And so I want that to be.
Well, that's a great idea.
Yeah, I know, right? That's awesome.
So it'll grab the photo and then turn it into like a PDF scan typed version. That dude, that's solid.
So that's.
Are you just gonna
cool.
You gonna try to monetize it?
Yeah, eventually, but it's slow going. I'm trying to make it all very scalable, very lightweight, all run by serverless models. So the AI has to be small. It
True.
has to be modularized, and all of that. So all of the above. But
That's sick.
yes. Hello. Oh wait, let me see. Hello, welcome. We're going to go ahead and get started. Let me remember to record this as well. Okay. I'm gonna check real quick. Actually, let me delete this part. Too many files. Open Windows. I want to see if they usually broadcast. Okay, yeah. Sweet. That is me.
Nice.
Okay.
So they started recording automatically.
Yes, yeah, they start recording for us at 7. So we're gonna get going. I think 1 or 2 people might show up after the fact. I was just saying how this was intended to be a long-term program, but a lot of people have dropped off because I give the option of them watching the videos online later, which is a mistake. I'm probably gonna fix that in the long run. Because this is our first pilot program essentially. Testing.
I think it works. Okay. The reason I use this specifically is that this microphone allows me to give enough audio for the cameras to pick it up. Because for the streaming and all of that, the microphone is somewhere up there for that. So yes. Okay. Well, thank y'all for joining. This is week 9 of Code Foundry, and start recording. There we go. Okay. So this is week 9 of Code Foundry. Our goal today is to talk about an introduction to DevOps and cloud. We're just going to scrape the surface. A lot of what we talk about is elaborated on further in the take-home videos. So please watch your take-home videos. This week's, I believe, are on implementing, is it serverless? Something having to do with serverless models, but it's somewhere in the presentation. Anyways, let's get to it. Okay, yes, so Tuesdays is going to be EC2, and then Thursdays is not going to be developing an API. I need to fix this. But it most likely will be another computing instance with AWS, so a tutorial on how to use that. And so today we are going to be talking about DevOps and cloud. We're going to do a recap on the architecture discussion we had a couple weeks ago. And that's really important, and part of why we're hitting home so much on that is that a lot of developers and founders don't understand how to properly architect an application. They have an idea of how to code something, but then when it comes to actually applying it, it's a million questions back and forth with ChatGPT. And that goes for me too. I've done that so many times in my career. So I just want to solidify on the different kinds of architecture before we move on to development, security, and operations, which is DevSecOps. And then following that, we're going to talk about cloud services, which includes IAM, identity access management, storage, databases, computing, and application deployment. So before we jump into it, a little bit about us. Hispanic Hackers is a nonprofit based out of Austin. Our goal is to democratize the tech industry for Latinos and Hispanic people. However, we are very inclusive. You can come in and be from any background, any kind of passion, and our goal is just to connect you with resources and where you want to go in the tech world. So whether that's starting a business or developing an application, we got that. And then this program is also sponsored by Circle Square Labs. Circle Square Labs is a full-service technology firm also based out of Austin, and they develop applications and websites for low cost with a team of qualified engineers. And then another one of our sponsors is Capital Factory. Capital Factory is our host for this meeting and all of our in-person meetings, and we're very thankful for that. So next we're going to do a quick recap over application architecture. Application architecture is really important because it's the foundation of how you build your app. So we're going to start by, again, just talking about the monolith. The monolith is the concept of your application where you don't have really a specific designated backend, right? This could just be a phone app that doesn't really have anything backend-wise. Maybe it's Flappy Bird or like a very basic app. But in this case, you have an application, you might have some external dependencies, maybe you pull in some libraries live, or maybe you are implementing a feature that connects with another player or user somewhere else. But the idea of a monolithic application is that you essentially have a single application with most of its dependencies and assets embedded in the application. So there's not a lot of change that you can do, say, in the cloud or in a external idea. In concept, to upload or update the monolith, you have to update the whole entire application, and the user has to go and download a new iteration of that application. So the monolith isn't the best model, really. It's only great if you have an extremely simple application. Now, the next kind of architecture that most people think of when they think of an application is front end, back end. And the way a front end, back end works is that you have the front end with its dependencies and assets installed on the user's machine. And that can update iteratively with UI changes or needs changes to the user's needs. It can have maybe some state that is persistent on the user's machine. But ultimately, we have a backend that's stored on a server or running on a server. And that server backend has its own dependencies, its own assets, and might connect to external dependencies, external resources, maybe a database, maybe like a service like Cognito, which does role-based access or access credentials for users. You could connect to a variety of different services as well as other computing resources, maybe an API to an AI model, etc. And so the front end, back end is very common. The thing is, if you want to change any part of the back end, you have to send an update to the whole back end. And that's not a huge issue when you have very specific singular changes to your application. You're not changing all the time. There's not a lot of changes to state, etc. However, if you have a lot of changes to different modularized parts of your backend, you might want to consider another form of application, which is containerization. What containerization is it is when we take our application's back end and we abstract it with a container. A container is like a wrapper around our application. And inside of that wrapper, we can hold other external dependencies, resources, and essentially we make our application be able to run on any operating system, any machine, because containers, all they require to run is a container runtime environment, which could be is essentially almost a virtual machine on your server. So that's why up here we have server/VM. We're running our container on a virtual machine with its dependencies, external dependencies packaged in. And the nice thing about that is that we can swap out this container with another container very easily as long as it meets the needs of the front end. And this gets further abstracted with the serverless model, which is what we're going to talk about next. But the last thing I'd like to note is that we can expose ports on our server to be able to talk and make exchanges with external resources. So next we're talking about microservice applications. So microservice applications further abstracts a containerized application where you have multiple containers working together. So here we have a container that is marked as an external resource, and here we have our backend container. But the fact of the matter is that you can have 10 containers connected together in a way that is coherent and is able to pass data between them. And the nice thing about that is, say you have multiple functions for your backend to perform, and these functions are very independent. All they need is some data from another function. What you could do is you could package each one of your functions or each one of your different programs as a separate container and then deploy them in a way that they are orchestrated to talk together. So one container can talk to another. And the nice thing about that is, say you have a backend that needs to process user data, and also another responsibility of the backend is to run a machine learning algorithm. What you can do is you can set two containers. You can create one specifically with the requirements that it has all the dependencies and assets necessary to log and manage user data, and then you have another container with all the dependencies needed to run a machine learning algorithm. And in this case, you can change out the machine learning algorithm easily without affecting the other parts of the program, such as the user data function. And so because of that, you can swap out containers. You can also make them modularized. So say you want to use that same AI model in other applications, all you have to do is install the ability to access that same container. And so that's what's really, really great about containers, is that they're modular, they can be easily swapped, and they give you a lot of opportunity and flexibility in that realm. Where microservice applications come into play the best is when you have a complex application that requires multiple back-end functions. In addition to that, it's also great for when you have a larger company or you plan to expand, where you want to dedicate a team to a specific function, such as you want a AI team working on the machine learning algorithm, and you want a back-end data-facing team working on the data portion. And so microservice applications are very, very popular, especially for big companies these days. And so if you're creating an app with big ambitions, microservice model is a way to go. Now the last thing, honestly, microservice models are great because they also apply to a serverless environment. And so this is the last architecture type that we're going to discuss. The idea behind a serverless environment is that we are leveraging services that cloud providers give us to deploy our applications. So just like all the other models we talked about, other than the monolith, we are going to deploy to a server. But in terms of serverless computing, we don't have to manage the servers. We don't have to dedicate server space or runtime. We don't have to do a lot of setup. And that's the nice thing about a serverless model. What a serverless model does is it allows us to upload our code into functions. And so, for example, here we have a singular function. And what we do is we hook those functions up to a gateway, and what that allows us to do is accept incoming traffic through an API to our function, and then be able to return responses from that function, with the function performing a singular action. With multiple of these functions, we create an interchangeable ecosystem where we can easily switch out different functions, different levels of code, and we can manage and serve a lot of different resources and assets very efficiently. And these functions have the ability to access other cloud provider services, such as a database, such as such as media assets. For example, in AWS, you'd use an S3 bucket and access that. You can hook it up to any number of services. And if you wanted to have a dedicated back-end application running in the background and connect that to a serverless function, you could do that too. So another benefit of a serverless model, and we'll talk about this a lot today, is that serverless models are pay-as-you-go, and they're pay-as-you-go in a way that these functions are not persistent. These functions don't always exist on the server 100% of the time. They spawn whenever they're needed. So in the case that you maybe have low traffic on your application between 2 p.m. and 5 a.m. or 2 a.m. and 5 a.m. and you don't want your application persisting and running the whole entire time while 2 a.m. and 5 a.m. occurs, these functions only spawn when needed, and they increase and scale in size when there's more higher traffic. And all of that should be managed by the cloud provider. And so that is the benefit of serverless, while microservice and containerized and front and back end models require that you manage your deployments a little bit more. You have to provide a specific image or a specific resource size. You have to specify the architecture, the resource size, all of these different factors that go into how you deploy your application. Serverless is much more simple, but there are also restrictions. And we'll talk about that a little bit more later on when we get into cloud services.
You have a question?
Yes, question.
Can they run in parallel and in series, or just series when it comes to functions and stuff?
Great question. So the question was, can they run in parallel and in series? And I believe they can. They have the ability to scale horizontally and vertically. And so that's the nice thing about functions and serverless applications, that they're really modular and flexible.
What if it's not serverless? Like it's on a server, you're on like the microservice one.
So the difficulty there is that you have to, in terms of a microservice environment, you have to provide the scaling functions yourself. So it is possible to do so and specify that. However, in a microservice environment, you have to configure that all yourself, versus in a serverless environment, the idea is that it's less managed, meaning that the platform manages everything for you. So you just specify things in the configs. And AWS, I use specifically AWS, but other cloud providers are very similar. They provide really great UIs that are simple, give you what you need to know and what you need to configure. Any other questions? Sweet. So next is the talk about DevOps. So DevOps, or DevSecOps, stands for Development, Security, and Operations. And so DevOps, from the start, is a set of practices, tools, and cultural philosophies that automate the integration process of software. So essentially, we set up automations for how our development environments turn into production environments and then deploy onto servers. And so our goal of DevOps is to provide a fast delivery, improved collaboration, automation, reliability, and continuous improvement and continuous development or deployment. And the main surrounding of DevOps in why we're talking about it today is that it is heavily connected with cloud services, in that we deploy using DevOps to cloud providers or to server providers. And so because of that, DevOps is exceptionally important when we're talking about cloud, because it's how our code gets there. DevSecOps is an elaboration of DevOps, which stands for Development, Security, and Operations, which highlights a security-first approach. So the idea is moving security from being a problem that we'll talk about later, and it's moving it to be a problem that we talk about now. So when you first start developing an application, how do you secure through encryption? How do you secure through resource management and proactively looking at the resources that you're bringing into the packages you're bringing into your application? This is also important in terms of delivery and how fast we can check security, automate our security checks before we actually deploy the application. This is an exceptionally important concept when you're working maybe with the DoD technology or government technology, anything that has government influence, such as healthcare or taxes even, all have to do with DevSecOps, because you want to make sure that that data is secured no matter where it goes. So that has to do with how you're transferring your data as well as how you're deploying your application. And so there are a lot of compliance policies that you must adhere to in order to adhere to industry standards for what you're doing. So medical field, HIPAA has its own regulations, so do DoD technology if you're working on classified projects, etc. And so the DevSecOps lifecycle starts with planning and developing. And the idea is that when you plan, you want to identify security requirements that might be necessary in order to realize your application. Developing, you want to use secure coding practices and running analysis tests. Building requires that you scan dependencies and libraries for vulnerabilities. And then testing for penetration through, you're trying to detect how can a malicious entity get control of this application or modify something that they're not supposed to. Then you release, you use container security scans and other tools to be able to monitor your application. You deploy, and with that, you want to operate and monitor with logs, metrics, telemetry, etc. So the last part of this is CI/CD, which stands for continuous integration and continuous deployment. This is the way that we set up our process for deploying our applications. And this is an important one. I used to work for a company that was creating applications that were used by a bunch of different users, young users really, and these young users needed access to this application all the time. But the company didn't have CI/CD practices in place, meaning that they didn't have staging for development, they didn't have staging for production. What they did is they made edits and they deployed them right away to production, which means that they automatically just uploaded all their code, errors and all, into the application. And this caused numerous bugs constantly. And I know that the young people that I was working with were just having an issue. The users could not rely on the application because it was always filled with errors. And so it's very important to put in practices that allow you to stage your application for development, testing, and deployment, and then after that, to have the right pipelines to check that your application is functioning and running with unit tests, etc. So that is CI/CD. CI is the first part, which stands for continuous integration. CI integrates code changes frequently, daily or per commit, and the idea is that you are integrating your code in a development stage. And so the process is developers commit code to a shared repository, automated tests should validate and catch issues early, and then this ensures that the new code integrates seamlessly with existing code bases. And the idea here is that you're testing early. Continuous deployment is the automation of releasing the application. So in this case, we have two different flavors. We have continuous delivery, where code is prepared, but we have to approve it as humans before it actually gets deployed to, everybody's phones or everybody's computers. Continuous deployment, on the other hand, is where every code change that passes the automatic tests get pushed to production. Continuous deployment is okay for like beta stages, maybe, but realistically, continuous delivery is the way to go because humans should always be checking to make sure that the application works before we push it to production. So the benefits of CI/CD are that you have faster deployment, you have a process in place for deployment, which results in improved quality, consistency, and there's the ability to collaborate, especially with code commits. And this has to do with how you manage your team to deploy your code and work with your code in terms of continuous integration and even continuous deployment. Assigning team members to maybe check on issues. This also gets into how you manage your project, but assigning team members to approve changes, assigning them to actually work on different parts of the application, etc., helps modularize how you deploy your code, and it really provides a much higher quality. CI/CD pipeline steps are managing your source code at the beginning by triggering workflows on code commits. So that would be using GitHub, GitLab, other code-based management applications. Building the application, so you build it, you can set up a pipeline to build the application after the code has been committed, and then running automated tests on that built or compiled application. And then finally, once those tests have been passed, say maybe you need human approval, but then you deploy to a production environment. So lastly, some tools for CI/CD would be Jenkins, GitHub Actions, CircleCI, GitLab, Azure DevOps, and Travis CI. These all allow you to create CI/CD pipelines that can connect between different parts of your application and allow you to stage for production and release to production. So let's see, what time is it? It's 7:30. We're going to jump into cloud services, and we're probably going to take a pause to have a water break. But in terms of cloud services are on-demand computing resources delivered via the internet. So the idea is that they allow you to host your application, they provide the infrastructure and the online capabilities. So this cloud services give you the access to databases, computing modules, etc., that you might need to realize your application. The key characteristics include on-demand, so you pay for what you use, you don't pay for something that you don't use. However, a lot of times your application, like a computing module like AWS EC2, will run the application continuously in the background, so there's no uptime, there's no time that it requires to start up the program or the application. And that is time that you're using, so you still have to pay for maybe stagnant time on your application or at a time where you don't have any traffic. Scalability is part of cloud services, so you're able to instantly increase or decrease your resources by scaling horizontally or vertically. Accessibility, so you can access your resources from anywhere with an internet connection, and a lot of this has to do with how cloud services will propagate your application to data sources or data centers in different parts of the country, different parts of your region, so that it's closer to you and it takes less time for your requests to get returned, essentially. And then managed services offload, so services that you don't have to manage yourself or that you can manage, so the provider can take on a lot of the management of servers and all the hardware that's super important for running your application. Some benefits are cost savings. So the alternative to cloud services is to just buy your own servers or rent your own server rack. And that's hard. I don't think really many people do that these days, especially with smaller applications. I mean, if you're going to create a giant company or you have a giant application, that is when it gets into the nitty-gritty of having your own servers. AWS has its own, Facebook, Meta has its own servers, obviously. Apple has its own servers. Not to mention that a bunch of other big companies do have their own servers, but having your own dedicated servers are more costly and you have to hire people to manage them, versus with cloud services, the servers are already managed by the provider. So it definitely saves on cost. It allows you to scale on demand via some sort of interface on your computer. A lot of times that's just a UI that the provider provides, or you can do so using your command line. So there's a lot of options in terms of accessibility, how you can access your apps and data. There is disaster recovery, cloud backups, typically propagate your app and the state of your app. So your databases, your data, etc., are backed up and kept on multiple servers across the country, across the world, across your region, so that not only are they quickly accessible, but in case, say, one of those data centers blows up, your data is still preserved. Security, there are a lot of security features like access control, so role-based access, encryption, etc. And then collaboration. There's a lot of collaboration ability, such as being able to assign roles in AWS and collaborate on certain parts, but also limit access to certain parts of the application to people based off of their role. And that moves us into cloud security. So cloud services follow a shared responsibility model. This means that cloud providers have to secure the infrastructure that you're using on the terms of the infrastructure that you are purchasing or renting, essentially. So when you pay for a cloud service, you are given all the terms up front on how the data is handled and managed, whether your application is sharing space with other applications or whether it's isolated. So the cloud providers must uphold their promises on security in terms of the infrastructure. However, customers are in charge of securing their applications, their data, and user access on their end. Some key security concepts include encryption, which is data being encrypted in transit or at rest. So if your data is encrypted when you store it, if your data is encrypted when you transfer it to the server, etc. IAM, which stands for Identity and Access Management. This is really important, and we'll jump into that right now, actually. So identity and, actually, do I have slides on it? Oh, okay, never mind. We won't jump into that right now. But we'll talk about that next. It's very important when it comes to cloud security. Firewalls, so you can set up firewalls in the cloud to block malicious traffic, specify exactly the policies of who accesses your application, etc. And then compliance, such as following regulations from HIPAA, CCPA, which is the California Consumer Privacy Act, GDPR, which is the General Development Privacy something. But these are very popular regulations and compliance requirements that applications have to follow. HIPAA is only for medical, but GDPR and CCPA are general for all applications. Tools for security. That's our last step. There's a lot of different security tools based off of your cloud provider. But AWS has IAM, which is their Identity and Access Management security feature. Azure has AD, and then GCP Cloud has IAM as well. And then in addition to that, you can set up cloud security posture management with other tools, which essentially give you frameworks for providing security features. So we're going to talk about identity, access, and management, which essentially is the rules that you provide on who can access what resources. And this helps you limit how much money you spend. Because, for example, if if you have just anybody using your API, that can really screw you over. So having specific applications that can use your different components of your server, your services, is very important. So IAM provides a security framework to manage user identities and control access to resources. Key concepts are users. So users are the individual people or services. So this could include maybe third parties who want to use your algorithm or your API, right? Roles, which are your set of permissions assigned to users, or groups. Groups are collections of users with shared access and permission, and then policies, which are rules that define permissions for users, groups, and roles. So at a very low level, you have individual users. Those users can be grouped into groups, and then these users or groups have specific roles, which are essentially the umbrella of activity that they work under, maybe front end, back end. Maybe they just work under AI or cloud deployment. And then policies are dished out to these different roles, groups, and users to specify what they're allowed to touch. And this can get really annoying in a company because a lot of times you might be a developer and have access to certain resources, and then you try to access a new resource, and you get this message that says, don't touch that. Like kind of like your parents, like, just don't touch that. And it gets frustrating because you have to go up the command line chain in your company to say, hey, can I get access to this resource? And they have to ask somebody else, can I get access? And it goes up the chain of command. But the importance there is that you don't want a user accessing a resource that they're not supposed to and maybe breaking something. I worked for a company where one of the employees deleted the entire backend for the GitLab instance that held all of our code. So immediately we lost all the code, like everything. Everything that the company created that wasn't kept on our computers was deleted from the cloud. So then they immediately sent a notice to all the employees like, look on your computer, like, do you have any of these applications that we lost? And we had to recover our code that way. And thank goodness for solid state drives, because if not, that company would have been in the dirt. So again, having role-based access is really important, because if you're working for a company, if you have somebody touch something that they're not supposed to, they can knock the whole entire application off its wheels. So some IAM best practices. The principle of least privilege, so only grant users what they absolutely need. MFA, which is multi-factor authentication. You get this a lot when you get like a text message saying, type this code into the boxes, right? Or when you get an email. These days there are much more advanced form of MFA, such as implementing a app that acts as a key. So I have an app on my phone called Duo Mobile, which whenever I need MFA, I'll just connect the two, and the Duo Mobile will give me a live code whenever I need it to access any resource. Audit and logging, so tracking who accesses what, and detecting anomalies. And then RBAC, which is assigning roles, privileges, and permissions to specific roles and not users or groups directly. So that would be grouping users into groups, assigning groups roles, and then providing policies to those roles. So some popular IAM tools, we just talked about this. We have AWS IAM, we have Azure Active Directory, which is Azure AD, and Google Cloud IAM. And before we move into anything else, one thing to note is that with AWS, and really with any RBAC role-based access setup, we want to create a company account. So say you're starting an AWS account for your company or your project. You want to create a company account because that's how you assign roles and permissions and policies right off the bat. And that company account has all the keys. It has all the access. And what you want to do is you want to take that company account and then create an admin account. And what that admin account does is you want to give that admin account full access and permissions. And then you want to take your keys to the company accounts and you want to lock those away someplace important and safe. And you never want to touch that company account again unless shit hits the fan. Because when that happens, then you can access the company account and figure out what's going on, which has full access and permissions. The admin accounts, you want to set up logging so that you know who's using the admin account and what for, so you're always seeing that and that's always going into the company account. So the company account really nobody has access to, but the admin account people do have access to, but it's being logged, right? And it's being checked on and it has full permissions. And then with that admin account, you assign groups, roles, and you bring on users, you assign groups and roles and permissions, and then you break down the permissions for individual users and based off of roles, right? So then in that case, say you bring on a front-end developer, you give them access to the front-end needs of the application. And say you bring on a database manager, a database engineer, you give them the needs that they need to access those databases, but they don't have access to everything. And that's essentially the best practice when you're working with role-based access in terms of identity, access, and management. So next we're going to talk about cloud storage and databases. We did just talk about this recently, and we're going to do a recap on it with some context for the actual service providers for these storage and database services. So when it comes to cloud storage and databases, we have a couple different providers and a couple different use cases. The first is object storage. So this is storing files, images, and media, like videos, anything really. And so to set that up, you use AWS S3, which is the S3 is simple storage solution, I think, or simple storage service. The idea is that all you do is drop in files. It could be images, it could be any kind of media, and it'll hold it for you. In terms of the equivalents for Azure and GCP are the blob storage and cloud storage. And so that gives you the ability to store your media. Next, we have file storage. This is file-based storage, so that's more text-based and shared drives. So in that case, we have Amazon EFS, which I think is Elastic File Service, and then Azure's and GCP's equivalents, which are Azure Files and Google File Store. Then we have block storage. Block storage is high performance, low latency storage for virtual machines and databases. So this is where all of their data lies. And this has more to do with volumes that are used by services. And so in terms of block storage, we have AWS's Elastic Block Storage, or EBS, I believe. And then we have Azure's disks, Google's persistent disks. And then finally, we have backup and archival storage, which is long-term storage. And these are data storage where you can kind of lock away access. I believe with AWS Glacier, you can lock it away for like 6 months and not touch it. And that's like the whole concept behind it, is to lock away data for some time and then be able to pull it out. And the nice thing about that is that it's a lot cheaper because they're not expecting queries to your storage. So they're not having to manage traffic coming in and out. Instead, you have access every once in a while. And so backup and archival storage provides long-term storage, and there's some configurations with that, such as using AWS Glacier or Azure Archive Storage. On the other hand, we have databases. So storage is more for large media files, data, or media and files, versus databases store parsed data. So data that's been given keys and values, essentially. And so we have a couple different flavors of this. We have relational databases, which manage your data in terms of tables. And we talked about this either last meeting or the meeting before, where our data is managed in tables, and the tables have relational schemas that can relate to other tables. So your, for example, user data can be cross-referenced cross-reference with maybe purchases that the users have made, or et cetera, but it's all compartmentalized into tables. On the other hand, NoSQL databases, which are the opposite of relational databases, are unstructured. They're held more in key value style pairs or in graph orchestration. And so the idea behind NoSQL databases is that it provides a less structured, but maybe a more fluid approach to how you develop your application. And this is great for if you have an application where you want to have more flexibility, essentially. You don't have fixed roles maybe for your users, but instead your users have a lot of different configuration abilities that change. And so NoSQL databases are helpful in those cases. Then you have data warehouses. Data warehouses are for big data analytics, such as machine learning, like weights and constraints and all that you have to deploy all of the large warehouse data level content. And so AWS has Redshift, Google has BigQuery, Azure has Synapse, and actually I don't think you don't store ML models in data warehouses, but instead you just store large quantities of data. And then you have data lakes, which is more what you use for machine learning algorithms, which is where you store raw, unstructured data for later processing. This can be, all of your training data, or maybe your constants and weights for your model. And so that would be using AWS Lake Formation or Azure Data Lake as an example. So I think we're going to take a 10-minute break for water and bathroom. So we'll come back at 8:05. Feel free to chat or get a water if you need it, and we'll be back then.
Do you all have any questions?
Do you know how difficult it is to set up and manage like a server farm? So like these places.
Yeah, I would say it would be substantially difficult.
Are you parking?
Yes. Does anybody need parking validation?
No garage message? No?
Okay.
Andres, you?
I'm all good.
You're good?
Yeah.
You know what you guys?
Sorry? No, I don't.
Sleep one.
Yeah, that doesn't hurt.
Does it make it free? After how long?
$8. So it's reduced, but really hurt.
It's crazy expensive.
Yeah, it is.
So it definitely helps. But parking on the street is free on these days, so that's what
Yeah.
made this spot. But how difficult it is to manage server farms, it depends on what you put on it, right? Like, are you talking about Bitcoin mining or?
No, like I don't know if server farm's the right word for it, but like AWS and these big companies that they have locations that hold all these servers that we're tapping into. Like to own one of those.
Man, it's got to be a really big process, because ultimately you have a bunch of different configurations that have to get installed on these servers, and the main thing is you have to update the software that will trigger all these updates to the servers. So their whole thing is AWS, GCP, the reason there's such a big barrier to entry is that they have all these UIs that us as users can go ahead and select our configurations and say, okay, I want this, I want this, I want this. And then when we deploy, it's easy. But on their end, they have all this software that gets run when we select our configurations to actually go and trigger maybe deploying a VM to a server. And so they need to constantly be updating that software. So they need developers dedicated to the software that's going to actually run the software on the servers. And then they need to construct the pipelines. It's such a big operation. Not to mention that actually managing and maintaining the actual hardware is important. So you need telemetry on the individual servers, and to be able to have all that telemetry going to a central location for managing like the hardware and making sure, hey, this hardware needs to be replaced, or there's an issue here. and then being able to scale on such a mass level. For example, AWS has data centers everywhere around the world. So being able to actually propagate a service or an application to different cloud regions was another reason why they have such a monopoly right now, or an oligopoly, is that it is such a large scale process to start something like that. But on a very basic basis, you can buy a Synology server rack and set it up at your house. You might require an expert to set it up, but it's not very difficult, and it just gives you media storage, but it doesn't have the software on it right out of the box to hold a database.
Yeah.
For example, you have to actually install the SQL runtime and all of that.
Yeah, I was asking because I know it's a very lucrative business, especially growing, but
Yeah.
to set it up, it's a lot.
Well, Amazon was pretty incredible because they started out as, a bookstore, and they're like, how do we manage our books better? And then not even that, they went online, and they're like, wow, okay, this is going crazy, let's add some different products. And they realized, hey, we need something to manage this product. And I'm sure that they used kind of service providers, and maybe they had a bad experience or something like that. This was before we had these giant cloud giants. So they're like, let's just create our own. And they started scaling up, hey, we need a database to be able to keep all of our content on. And I'm sure they already had databases, but they're like, let's make this modular so we can deploy for other people's applications. So they iteratively grew. I love to create things, so my goal as a developer is to create modular applications that can then become something a lot bigger.
You go.
Yeah. Have we met before?
Yeah, I'm Alex.
Yes, that's right. Okay, yeah, you've been coming for a while, right? You came to the last couple?
Yeah, I wasn't able to make it to last month's, at least in person, but yeah, I've been going to the Bootcamp every Monday.
Thank you for coming, I appreciate it.
Yeah, sorry I was late. Traffic is really bad going northbound in 35.
Totally
I live
get
in
it.
the Georgetown area, so it's a bit of a drive.
Yeah, that is. Thank you for coming. I appreciate it. Our attendance has dwindled, especially in person.
Yeah.
I'm sure you've noticed the online meetings got a little bit smaller and
Yeah,
smaller.
just shrinking little by little.
But I think the main projects that are sticking are Ion, yours, Jeff's, and I think we might have one or two other people.
Okay.
But how's your project coming along?
It's coming along, that's for sure.
Yeah.
But
You're doing the extension, right?
the Firefox extension.
Your Firefox.
Yeah. I spent a majority of the time just kind of, as I told you last time, looking at a few open source projects and related software to kind of get an idea of how it all works. And I feel like I overestimated it, or just not underestimated it. But yeah, I would say within a few weeks I should at least have a basic UI set for having subtitles, at least directly from Netflix, rather than having it go through DeepL or similar software. But yeah.
You're slowly taking off the crutches. Right?
Basically, yeah.
Yeah, that's good though. That's smart.
We'll see.
Yeah.
What's your project?
It's basically going to be a dual subtitle extension for Netflix or YouTube. Kind of help with language acquisition. And originally the goal was to have it have the official captions translated directly through AI, just for more accurate translations, because I've noticed that with Netflix dubbing, or rather the subtitles in different languages, they're very different from what the dubbed actors are actually saying. So I figured translating it directly from the English captions, or yeah, would be much more accurate than what they're
The interpretations.
yeah.
Would you get your goal is to monetize it?
Maybe, but we'll see where it goes.
I feel like if one of the companies like took wind of it and loved it,
Mhm.
and they bought it off you, that'd be nice.
That'd be sick,
But it's like if you, it would catch fire if it works really well, and you
Yeah.
offer it for free. I feel like Reddit communities would take off with it.
Oh, for sure. I mean, there's a few like Language Reactor. There's also Migaku. Issue is it's only available for like Chrome, and I want it to be available for like things such as like Firefox specifically.
Why? Just less resource heavy?
Not less resource heavy. Well, I guess compared to Chrome, yeah, but it's just I've noticed that Firefox's extensions are just very sparse in comparison. It makes sense because it has a lower
User.
yeah. So yeah, it was more me solving my issue, just like me preferring Firefox over Chromium. So it's just like, might as well build my own thing.
Okay. What time is the meeting supposed to end?
We typically end around 9, but it's probably gonna be a little bit earlier. Yeah.
Yeah, I didn't realize the time. I gotta go.
Okay.
But do you have your info on the event page or something?
Yep, I'll switch in. Oh.
I'm also curious, I feel like it'd be cool if there was a.
Like this?
Yes. Let me try to remember.
Yep.
What are these looking at?
Sounds
Or
good.
just do the slide and tab thing.
Oh, yeah, like the whole, that thing.
There we go.
Nice.
And is there some kind of like social event that for devs or in town that's pretty popular on like a routine basis?
We do socials sometimes, but not so routinely. I would say the best place to go would be Tequeria. They
I've
do
checked them.
socials as well, for Latinos, and then it's mainly us, Tequeria, and then Latinas in tech, but I think that they're kind of quiet right now. I haven't still heard of them in a while, so, it would be Tequeria. We're trying to do more socials, it's just right now it's me managing everything, and I've been really busy with this, but,
Fair.
we'll be done with this in January, so the idea is we'll have like a month break before the next cohort, and we'll probably host a couple socials then.
Cool. Alright, well, good meeting you guys. Take care.
Nice meeting ya.
Yeah. Hey, good luck on the project.
Oh, appreciate it.
Alright, we're going to get back on it. So, talking about cloud computing. Cloud computing is the next step of the piece of the puzzle, because now we know how to store our data and manage this data storage, but the next part is how do we actually access our data, and we can access it in a development environment by using APIs, etc. I mean, there are libraries that allow us to access these cloud services, but we have to deploy our application somewhere. So, cloud computing allows us to deploy our application onto server hardware. And there are a couple different principles here. The first being infrastructure as a service, which is IaaS. This is providing virtualized computing resources, so servers, storage, and networks over the internet. The main infrastructure as a service process or provider that's being used for cloud computing is AWS EC2 or Google Cloud's Compute Engine or Microsoft Azure's VMs alternative. Essentially, that gives you a virtual machine to deploy your code onto on a server, and the virtual machine can scale. The thing is, with EC2 or its relative services, scaling and configuration requires a lot of management from our side, because these services have kind of a 50-50 split with how the service provider manages and how we manage. So there's a lot more responsibility with running an EC2 instance in terms of making sure that it all works with your dependencies, all works with your application, and that it scales and provides the resources needed for your application. So some features are virtual machines, resource scalability, and full control of the operating system and applications. So you can decide what operating system your application gets deployed to. For example, say you need a Linux environment, you can specify which Linux platform to use. And then finally, the use case for this would be for having full control over the operating system storage and apps, ideal for custom app development and legacy systems. But I would say steer clear of this if you want a more lightweight and resource computing, I would say less resource intensive alternative, because EC2 instances, although you can specify how much resources you're going to use in maximum, it's more flexible, but flexibility causes more complication, right? It's more convoluted. So I always steer clear from EC2 unless I absolutely need it. I tend to aim for a platform as a service system or a alternative, possibly serverless or containerized environment, which we'll talk about next. But the next term is platform as a service. And this allows you to work and develop on your application and focus on your application's development, testing, and deployment strategy while providing a platform that has rapid development and CI/CD support, and auto-scaling features. So in this case, the platform as a service model typically gives you a lot of what you already need to develop your app, including possibly built-in databases, etc. This is your AWS Elastic Beanstalk, Google's App Engine, and Azure's App Service. And the use case here is when you want to focus on coding and not infrastructure. It's ideal for developers building and deploying apps quickly. Next, we have container development. This is where you package your application in that container that we were talking about, and you deploy it. And the nice thing about this is that you package your dependencies in your application, and you're able to test it modularly outside of the environment, the infrastructure that's going to run on. And so container deployment is really great. You can use tools like Docker, Kubernetes, AWS's Fargate, or Azure's Kubernetes service. AWS also has the Elastic Container Service for running containers and the Elastic Kubernetes service. The difference is that ECS, which is Elastic Container Service, is more specific to, or it's more general to running any container, while EKS, or Elastic Kubernetes Service, is specific to containers that are orchestrated using Kubernetes. And we're going to talk about container orchestration and development next week, or not next week. So one thing is we're skipping the next 2 weeks due to winter break and all of that fun stuff. But we are going to come back January something, and that is when we'll talk about containers. So containers are really important. I think that they're the ideal method when you have a complex application that doesn't fit the serverless model. And so some features are portability, microservice support, and app isolation. And the use cases for microservices, portability across environments, and consistent development and production. And then finally, we have our favorite, serverless computing. It's my favorite because it's modular and it's very cheap. And that's the nice thing. I mean, it's not so cheap, but it's cheap. Because you only run a serverless environment when you need it. So some key providers, you might hear AWS Lambda, Azure Functions, or GCP's Functions. And essentially, serverless computing allows you to run code on demand without having to manage servers. This is setting up event-driven functions. So the idea is you can trigger a function or a program whenever you make an API request. Or maybe when you upload data to a S3 bucket, or to for example, you update data to media storage. it will automatically run a function for you to process that media. So serverless computing gives you a lot of different tools for being able to run events-driven code. And so some features there are event-driven execution, auto-scaling, and pay-per-use. Use cases are when you have event-driven apps, lightweight microservices, or reducing costs by paying only for execution time. This is my ideal. And the reason why I say that is that you can create a small microservice function that will go ahead and update your database. And you can upload that into and connect it to an API. And then whenever you make a request to your API, it will trigger that update to your database and check maybe what your request on the way through your function. Or say you want to run a very lightweight machine learning algorithm model. You can upload the binaries to Lambda, and the nice thing about Lambda, or any serverless model, I know specifically Lambda has a 250 megabyte maximum file size requirement. But the nice thing about that is that it gives you the opportunity to add layers, which are abstractions of your function. So your function has to be within a maximum size, but you can add binaries to a layer which you access from the function. So say you want to add a machine learning algorithm to your application. You can put all the binaries required to run that machine learning algorithm in a layer and then access that from your main function. And so the nice thing is serverless computing gives you the ability to modularize and really focus on optimizing your application. And it gives you the ability to run event-driven methods. So I wanted to jump more into platform as a service because we've been talking a lot about serverless computing and container deployment. We're going to talk more about container deployment next week, or not next week, but 3 weeks from now. But platform as a service is important. And the reason why it's important is that it allows you to quickly deploy. Just uploading your app, and AWS handles the server setup and configuration. It supports a lot of different languages. This is specific to the Elastic Beanstalk, which is AWS's platform as a service model. But this can also correspond to other cloud providers. But Elastic Beanstalk supports multiple languages like Node.js, Python, Ruby, PHP, Java, .NET, and Go, all of your basic web languages, essentially. It allows for auto-scaling, so it can automatically add or remove EC2 instances to handle traffic changes. And the idea behind platform as a service is that it's a more managed EC2 instance. So your code is running like it does in EC2, but instead of you having to go ahead and manage all the configuration properties for that EC2 instance, AWS or the corresponding service handles that for you. So you can just focus on developing your code. Health monitoring, so there's the option to connect to CloudWatch, which will provide health monitoring to your application. Simple management, so providing a dashboard with version control, logs and status updates, and then also providing customizability, so being able to use configuration files to customize EC2, RDS, load balancers, etc., which are all services that you can connect to your Elastic Beanstalk instance.
So, no, I guess that answers it. But with infrastructure as a service, you're essentially given like every tool laid out in front of you, basically.
Yeah.
Does that already come? That doesn't come packaged with it, right? You have to like get the other services from like AWS or like Azure or different, services provided by them. For example, like S3 or a few other things.
Yeah, with for example EC2, right? It is much more fluid, where you have to specify all the configuration yourself. You have to specify the ins and outs to connecting to other services, etc. And you also, the main thing is you have to specify what your program is going to be running on. Versus with Elastic Beanstalk, AWS can audit your application for you and figure out what your application needs to run on. It might not be as efficient as if you finely tuned everything in EC2, but it also gives you some quick connections to configuring for RDS or load balancing, things like that. Versus with EC2, you have to set up your own load balancers, which will allow you to manage incoming traffic, things like that. So you have EC2 where you have to set up a bunch of smaller services to support it, versus Elastic Beanstalk gives you that out of the box with less configuration requirements. The thing is that it's not as quick as deploying maybe serverless or containerized. And it's not as modular as containerized, and that's why you use a containerized architecture instead if you have a lot of different modules. Does that make sense?
Yeah. Thank you.
Yeah, of course. And so the typical process for a platform as a service is you upload your application code by deploying using supported languages. You configure your environment, so provision services, load balancers, auto-scaling, and monitoring tools by just filling out some configuration UIs. And then automatically deploying with CI/CD, so deploying the application to environment and managing the updates. And then monitoring and scaling, and Elastic Beanstalk or your PAS model will handle performance monitoring and auto scale instances based on demand. And so this is a comparison of some of the features that each of these different platform as a service services give you. So you have Elastic Beanstalk, which gives you high customization ability, a lot of auto scaling via auto scaling groups, language support that's very wide, and then you have deployment with CLI, Git, or AWS's console, which is online. There is free tier use, but limited, and a managed database that comes with AWS RDS support. On the other hand, Heroku has more limited customization. It does have auto scaling, but the language support isn't as wide. You're missing Java here, and I believe Elastic Beanstalk has more language support too, if I'm remembering correctly. Deployment, you can deploy with Git, but you have to use Git push. There is no free tier for using Heroku, and the managed database is an add-on only, so you have to really configure it yourself. And then Azure gives you moderate configurability. There is auto scaling. The language variety isn't as wide. You're missing Ruby and Java, and then Azure Portal can be used, or the CLI to deploy. You can also deploy, there's also a free tier, but it's limited, and you can integrate with the Azure database services. So, last things, we're gonna end on these notes pretty soon. We're talking about cloud service applications, so this is how we kind of wrap everything together. And so when it comes down to it, web and mobile apps benefit really highly from serverless backends using AWS Lambda, Azure Functions, Firebase, or Vercel, or Netlify functions, which all provide different function models for you developing and deploying lightweight applications. When it comes to data analytics and AI, you can run big data processing with a bunch of different service providers, such as AWS's EMR, GCP's BigQuery, Azure Synapse, Databricks, or Snowflake, which are third parties as well. And I haven't worked much with data analytics or AI, but those give you a lot of different options for models and data storage. And And then when it comes to backup and disaster recovery, you can use AWS Glacier or Azure Backup for backups. When it comes to media and content delivery, you can stream using CDN, or stream and provide CDN using AWS CloudFront or Azure CDN or Cloudflare, which is another very popular provider. When it comes to Internet of Things, it's typically creating a network between devices, and for that you can manage it with AWS's IoT. Google and Azure have their respective services, and then ThingSpeak is also a very popular one. And then finally, for DevOps and CI/CD, you have AWS's Code Pipeline, Azure DevOps, GitHub Actions, Circle CI, all the ones that we've talked about. And so when you're looking at this, you might notice that we're missing infrastructure as a service providers like, for example, EC2 instances, so your actual kind of core computing services. We're also missing containerization services, and those really come into play when you have a more abstract application. If you want a fully managed application where you can fine-tune everything, I would say go for EC2. But make sure that you're an expert on your application and you know what you're doing when you're deploying. And then when it comes to something that's more broad but also requires a lot of configuration, I'd say platform as a service services like Elastic Beanstalk are really helpful. And then finally, if you want a lot of modularity to be able to swap your containers around, use a containerization service like ECS or EKS, which are Elastic Container Service or Elastic Kubernetes Service. And those allow you to deploy containers and run them in containerized environments. And then finally, we have databases, which you can use a bunch of different kinds of databases or data storage, which we've also talked about. So those are like the core aspects of cloud services and cloud development. And I feel like this really sums up what is the current ecosystem in terms of cloud providers. Some cloud service trends include serverless computing. So there's a lot of focus on creating small, modular, lightweight functions that can do the same work as, these giant programs and connecting them together. There is multi-cloud strategy, which is a lot of people use cloud services from multiple cloud providers. So they'll grab, maybe a database, they'll use, Google Cloud's Firebase, and they'll match that with maybe an EC2 instance. And that's great. Vendors try to lock you in to using their products by providing really easy interconnectability within their services, right? So they'll be like, hey, you already have a role to do this, and you already have this application here, just expose this port. It's super easy to connect to this database. And that's great, but vendors will lock you in, and it's really hard to move to a different cloud service provider if maybe they increase their costs, right? Because inflation does happen, and eventually AWS is going to be charging maybe 2 times the amount that it does today. And what if Google Cloud's cheaper for what you need? It's going to be hard to change that over. So multi-cloud strategy is really important, and another thing that's very important is making your applications be able to fit into any cloud service. So for example, if you're developing a Lambda function that you want to run on AWS Lambda, so a serverless function, use a serverless model for defining how your function is laid out instead of using the AWS SAM model, which is their model for serverless applications. Because if you use the AWS SAM model specific to deploying on AWS, and then say if you want to deploy to Google Cloud instead, it's more difficult to switch it over. And then we have edge computing. Edge computing is very popular these days because it pushes the computation to the edge where you need it to be. So to data centers closer to you to reduce the latency back and forth in terms of how fast you receive your your responses and you send requests. You also hear that a lot of the trends are for AI and machine learning. So AI and machine learning services like AWS's SageMaker or GCP's Vertex AI, Azure's machine learning, these are very popular these days for setting up big AI models. And then finally, sustainability and green cloud is the focus on reducing carbon footprint with energy efficient data centers. This has become a trend recently as well, as we have a very, very hot winter here in Austin. So it makes sense that people are starting to focus on like greener motives and reducing their carbon footprint. So last thing, if you please go fill out your attendance, both online or in person, regardless, please fill out your attendance. It just helps me know who's shown up to the meeting. And if you're not regularly attending our sessions, say you are at home right now, or if you're not regularly attending our sessions, feel free to just put that you have no project or you're working on your own project when it asks you. So that, because you're not working on any project in the program. But I'll give you all a couple minutes to do that, and then we'll wrap things up.
So were you a DevOps developer before? Or are you?
I was not a DevOps. I was more full stack. I actually started out as an embedded systems engineer, so I was working with IoT and all of that. And then I moved to software for DoD, so I was working on defense software for a while. And then from there, I left the company that I was working for, and now I do contracting.
Okay.
So I do the whole 9 yards, develop, deploy, all of the above.
Nice.
Yeah.
All right, sweet. To wrap things up, we're going to do project check-ins in a sec, but I just wanted to mention that we will have a take-home video coming out this Tuesday and Thursday, and I didn't finish this page, but our next meeting will not be for 2 weeks from now. So we won't have that meeting, or not 2 weeks, 3 weeks from now. So next week and the week after that are on break because of winter. I mean, we have Christmas and New Year's, and it's a much needed time of rest. And then we'll come back after that. I think it is January, what today? We'll be back on January 6th to talk about containerization. And then the last thing we have to mention is Capital Factory has been our gracious host. We show this slide at the end of our Capital Factory meetings to thank them for providing the space for us. It's a great community, and I've worked here before. It's just a super chill place to work. It's a great place to find contracts if you're a contractor. It's a great place to get networked with startups and other people who are working on fulfilling their dreams. So thank you to Capital Factory for hosting us. And that is it for today. We're going to do project check-ins. If you have a project, please stick around. We'll get to the people who are online last. But we'll go ahead now. And if you don't have a project, you're welcome to leave or stay and chat. More than welcome to do anything you'd like. So thank you all for attending this meeting, and we'll see you in 3 weeks.
How's your project going? So we talked about your project. What's your main struggle right now? Is just getting off of the services, or like the intermediate?
Yeah, it's mostly like intermediate, like creating like a pipeline between from like, or rather getting all the subtitle information of the XML documentation and then sending it over to DeepL and then getting it back.
Okay. So
Yeah,
it's-
like having DeepL like translate directly and then putting it into its own file, receiving the file back. For me, like, I've had, I still am having a bit of problems learning how REST API works, and that's my main area of like trouble.
How so? Is it like cores management? Like cores can be a pain. I always run into cores issue when it comes to
A bit of both, really.
APIs and REST. And then you mean in the way that like the REST API, we can really go into this much. REST API is a framework, right? And like you're having a complicated time trying to understand how it sets up the rules for creating an API, or
Basically, yes.
okay. So the idea is that we have our methods, right? Like the delete, post, get, and that's pretty simple with post. We did talk about what post can, like what post is, what each one's used for. But the idea is just the general how you set up your API to execute that.
Yeah.
And then you have middleware in between. REST APIs are the most common, but they can get complicated and messy.
Yeah.
If you have any specific questions, feel free to shoot them my way. Like,
For sure.
I'm more than happy to help.
Well then.
Yeah. Sweet. Okay, I'm gonna move on and, Jeff, how you doing? Turn up my volume now.
Hi, Greg, how are you?
I'm good. How you doing?
Yeah, really hectic week. I remember what I told you.
Yeah, and thank you for showing up, regardless. I appreciate it.
How has it been for you? Feels like a lot.
Yeah, tracking the end of the week.
Yeah. Like, so very much.
Not a problem.
Yeah.
Missed out on some food.
That's why.
We actually don't have food, so don't worry. You didn't miss out on anything.
Yeah.
Oh, well, Eddie's pretty
But
good
yeah,
about food,
like,
but, decent amount
I
of
can
food.
understand it conceptually, but like applying it
Yeah,
is like a totally different story.
Go-
You know?
So, yeah,
I feel like you covered like a semester's worth of like.
Yeah.
you know, I'm amazed at,
The key is just like
how you're able to do all this.
applying it.
Yeah.
I think that's
I've worked on projects at work,
What about you?
Oh, this is my first time joining this.
Oh,
Yeah.
nice, okay.
I like it so far. They're good. I need to be picked up.
Oh,
But
Yeah, I mean, thank you. It's a fun operation. I love what I do.
I think I'll come more in the
And,
future because it's.
I'm hoping that
Sure.
next
It's really important.
year, our second cohort's gonna be even better because I'll be more prepared. I've been making up the rules as I go. And I'm learning how to teach still. Bye, Clarissa. It was nice meeting you.
Nice to meet you.
But I appreciate it. Do you have any questions or anything that I can help with?
You asking me or is it?
Uh, You, sorry.
Math is fine. I mean, high level, I understand what you're saying, low level, I have to actually work on it.
Yeah, I gotcha. No, it makes sense. It is difficult to, like, I'm trying to do my own side project right now. I just get so caught up in it sometimes. If you need anybody who's an expert on something specific, let me know too, because like I'm not an expert on AI. And I know that your project doesn't have AI, but as an example, I need to reach out to people even for AI help and a lot of different things. So it doesn't hurt to help, ask it for help sometimes if you get confused. But I know that you've just been busy. So just keep hanging on in there and let me know if there's any way I can help.
Yeah, I've actually done some AI stuff just not recently, like this Canva exposition.
Yeah, that's awesome.
It's pretty insightful.
Yeah.
We'll talk more later.
Yeah, that would be really cool. Alrighty. Well, if you don't have any questions for me, I'm gonna start packing up. But thank you for attending, and I will see you in not next week and not the week after, but 3 weeks from now.
Right, 3 weeks.
Alrighty. Have a great holiday. Merry Christmas.
spending as much time on the project as I wanted to.
I feel like that's always how it is.
Yeah.
I never end up spending the time that I want to on projects, but it happens. You gotta pay the bills, you know, like
Yeah.
do all the manager stuff, and it's hard.
Definitely.
Thank you for coming. I feel like our cohort's been kind of dropping off a little bit,
Mm-hmm.
and I am accounting that to not having a lot of dedicated not dedicated projects, but not having a lot of startup projects.
I hear
We
ya.
had one startup project, and Ion's still going strong, which is
Mhm.
great. But it means that the only people who are attending meetings right now are typically Ion people.
Yeah.
And you and Jeff. So,
I gotcha.
it's a note to self. Another thing is, I think I'll make meetings mandatory, next cohort, and I'd love to get your feedback on this. Next cohort, I was thinking about putting in this model, where right now the issue is that when developers are helping out the startups,
Yeah.
founders, there's no legal model for them to have an exchange of services. Because if you think about it, the developers are doing stuff for free, and later on they can claim, hey, that's my intellectual property.
Yeah.
And so the idea is that there needs to be some level of compensation that the service, that the startup entrepreneurs are providing the developers. And what I was thinking is, what I've been advised is that maybe the program can be paid. Like it could be like a paid program that people have to pay for.
Mm-hmm. Like, people as in developers working on the startup project, or
Everybody who comes into the program.
Okay.
And the compensation that is given is that the startups